Hello, in this video I am going to use the Footprint Company Lifecycle Carbon app in Giraffe to design 3 residential towers and compare the carbon content. And this is epic. So first thing we've got to do is design one residential tower. So let's do a 40 by 19 meter residential tower that has 25 levels. And I'm going to add a few things to this that I explicitly want to control. So the first is the floor to floor. I'm going to set that to 3.2. And the second is the label, just so we know what's going on. And I'm just going to, before I do that, I'll add a building ID property. Let's call this building A, that's good. And I'll just set the label to the building ID. Building A, and just drop that. And I normally hide the background because it looks better. All right, so we've got building A. Now, I've added the Lifecycle Carbon app to the project. There's no information. Some buildings are not being configured, it says. Click to fix. I click, and you can just see here the Footprint Company Lifecycle Carbon app in the usages editor of this building. So I'm going to include it, and I'm going to set my assessment mode to detailed. Now, this is detailed. This is about building. So we've got to select what type of building we want, because in the Footprint Company database, they obviously have many different buildings. So this is Class 2 multi-residential premium above 25 meters, and we are in the great nation of Australia. So I can configure those. And now what I'm able to do is for the structure, the facade, the services, the internal and the external elements, I am able to either benchmark my building, so just say, hey, I'm going to set this to average, right? And if I do that, you can see there's best practice and there's my average practice for structure. But what instead I'm going to do is I'm going to choose some materials. So I'm going to go Class 2, and I'm going to do a conventional concrete for this building. And when I do that, we're actually using real systems. So I have to go through and do this all, properly. So let's do double glazed curtain wall with 85, manufactured in China. Let's do that. Services, I'll filter down to Class 2 again. Conventional metal duct. Let's just go like heaps conventional. So Class 2 here, I'll go average practice, and I'll go 3-star average practice there. All right. So now I have my building with its floor to floor 3.2, it's 25 levels, and its structural systems set. And I can see that this building is going to emit 116, or is going to embody 116,000 tons of carbon, as opposed to a fully 5-star building. Best practice and everything would be 54,000 tons. But it's not good enough for me to say to my client, just do best practice. So let's just start pulling some levers. So I'm going to copy this building. Now, generally when you're doing options, you don't move them around in space. You'd use the layers and you'd sort of build them on top of each other. But just to drive the point home, I am going to just copy this building, next to each other. I'm going to call this one building B. And the only thing I'm going to change about this is, instead of conventional concrete, I am going to use Class 2. I'm going to use conventional post-tension concrete. So same facade, double glazed, same servicing strategy, all the same. Just instead of conventional concrete, I'm using post-tension concrete. And you can see that immediately building B has gone from 116,000 tons to 87,000 tons. So an enormous carbon saving by using this construction method. Now, the other thing that is cool about the post-tension is potentially I can save the floor to floor, so I can lower this thing ever so slightly. And by, it's because my structure is skinnier and post-tensioned. You've got to ask your engineer if this is indeed true, but let's say it is. By taking that 0.2, so that 100 millimeters off every floor, you can see there, the building's slightly shorter. I've gone from 87 to 86, so I've saved 1,000 tons, 1,000 tons of carbon. Now I'm going to do one more optimization, and I'm going to copy this. I'm going to call this building C. It's short. It's using an efficient construction methodology, so it's saving carbon. It's the floor to floors, done. What I'm going to do is I'm going to round the corners. I'm just going to round them by, say, to 10 meters. And when I do that, the area of this building starts falling. So if I go my areas by, you can see 15,000 as opposed to 16.1. We're on 15.2. So what I'm going to do is I'm just going to grow it. And I'm looking at building C here. We're at 15.7, so I'm going to have to grow it a little more as well till we hit that 16.1. Oh. Okay, so now we have parity on 16.2. That's close enough. We have parity on area now on GFA. But if we come to the life cycle carbon, you'll see that building C is down at 85. So I've saved building C and building B both have the identical structural system, facade system, servicing strategy, and internal and external finishes. But the geometry of building C is slightly different to that of building B, and we've saved an additional 1,000 tons of carbon. So building B has 86 kilotons of carbon, and building C has 85 kilotons. Now, it may not make sense to round the building out like this. You know, the apartment floor plan, it may not work. The costs may be prohibitive. The post-tension structural system may not operate with it. But isn't it cool to be able to discuss those trade-offs in real time and quickly? And I'll just run one more argument here. Let's say we were going higher. Let's say we were up at 40 levels. Let's say this was like, you know, legit. Now what you can see is, if I don't zoom, is that those 100 millimeters less per floor that the post-tension buildings have over those 40 levels has added up to enough for an extra level. So we could these guys to 41 and still have the same height, the same visual impact as this building as building A, because it's a more efficient. Now the area then of those buildings is going to be bigger. So if we look at by building A is at 25 and these guys are at 26. So there's an extra 800 square meters, very premium, 800 square meters. So your FAR calculations or your FSR calculations, you may be over. But you would be able to run an argument that you are, by doing this, you're decarbonising, the extra money can be used to pay off the additional, the structural optimizations, right? So you go from the conventional concrete to the conventional post-tensioned, and suddenly you're really working at like a, you're pulling the financial lever, you're pulling the planning levers, and you're pulling the design levers to find a really, a good outcome. Okay, so hopefully that is informative and shows you how we can tie all of these things together to create planning arguments. The final thing I'll show you, and this is for the technical amongst you, is just how to say this in a usage, right? So that configuration job, quite intense. You may not want to do it every time. So what I'm going to do is I'm going to hoist this configuration, this facade configuration, into a new low carbon residential. So call building A with the conventional concrete, our conventional residential typology. It's got this floor to floor of 3.2. And let's call this one with the post tension, let's call that a low carbon residential typology. Okay, so the way I do that is I reach into the data and I find the life cycle carbon data, and you can see there's quite a lot of data, nested data down there. And I'm just going to copy it. And then I'm going to go into the app.JSON editor. Residential. You can see here's my residential use. And sorry, before I do that, I'm actually just going to use the normal. I'm going to create a low carbon residential here. Typology here rather than doing it in that text editor. Okay, so that being done, back to the app.JSON editor. Let's go find our low carbon residential. There it is. And in this join table, in this key here, I'm literally going to paste that life cycle carbon key, right? And when I save, that'll reformat the JSON. And that's it. So now if I or my team draw a low carbon residential building, and we go to the life cycle carbon and go by building, you can see that it's already pre-configured. You can see this building has the building ID local 9. So if I give it a building ID and I'll call it test, you'll see there's the test building. And so it says you can include it here to override the defaults, but those defaults are actually being read by the Lifecycle Carbon app. And that's the way you can, for your design office, kind of customize this so that your designers and your master planners are not having to repeatedly configure the Carbon app. And that's all. That's how you sort of scale this out. Thank you.